what this is all about, we're doing here. See, in general what happens is I might tell you that something is normally distributed. For example, in the book today, we're going to talk about people's heights. People's heights lie on a bell curve. If you have lots and lots of data and you plot it, you're going to find, so let's say we have adult men. You're going to find, that's not a very good bell curve. Let's try again. That's a little better. Here's the x-axis, let's say. You're going to find that they form a bell curve. Now, what's different here? Well, instead of having z-scores, I'm going to have an x, where x is, let's say, the number of inches tall we are. Okay? And I'm going to have, right in the middle here, a mean, right? Mu. But is my mean going to be 0? No. Anyone know what the average height of an adult man is? I remember hearing 5'9", which is my height. But I think our book says something different. Let's see what our book says. Let's flip ahead to... Oh, okay. Actually, that's what they say. 69 inches, 5'9". If you look on page 273, this is according to the National Health Survey, whatever that is. But they say that the mean is then 69. And remember that this is what I'm going to call the x-axis, not the z-axis anymore. Z is number of standard deviations away, and z is also what you get on the standard normal curve, right? X here could be any random variable. Here, x is how many inches tall we are. So I'm right at the mean. How about that? Average Paul instead of average Joe. All right, so now, yeah, the 50th percentile. It says that the standard deviation is 2.8 inches. So that means, remember, the standard deviation is about where the curve starts kind of changing from concave down to concave up. Right about there, and right about there. And we said sigma is 2 point what? 2.8 inches. Okay. So if I were to add 2.8 inches onto 69, that would be right here. I guess that'd be 71.8, right? Is that okay? Sigma is given. Yeah, I mean, we got it from the National Health Survey. What page am I on? Page 273, and I didn't have a number picked at all. I'm just giving you some data. Yeah, I haven't really started working on a problem exactly yet. But what I am doing is I want to show you real data. Right up here, directions in blue, it says, right? That's just some info about men's heights. Now, we are going to solve problems where your first step is probably going to be to draw this picture. But this picture represents men's heights. Okay? And I like how you said I'm at the 50th percentile. That's what we mean, right? Half of the men are shorter than I am, and half of the men are taller than I am, according to their data. Okay? Now, we don't have a table in our book that says anything about the area under this curve. Okay? So the trick is we're going to convert this to a standard normal curve. That's right. So how do I do that? Well, our beautiful conversion formula. Z equals x minus mu over sigma. Oh, that's not bad. Get out of here. Well, you say another formula? Well, yeah, it's a formula. But it's going to be easy to use. Actually, if you guys had a calculus class under your belt, I'd be able to show you exactly where this comes from. But we don't, so I'm not. Okay. Now, that being said, I can still show you why the formula makes sense. Here, watch. What you do is, for our example, so in our example, Z equals x minus, what can I fill in for mu? 69 over 2.8. Well, yeah, that's a variable. X is a random variable, and Z is the standard random variable. Z is what's called a Z-score. Hey, wait a minute. Z-scores. Didn't you guys already compute Z-scores? How'd you do it? Didn't you have a formula for Z-scores? Wasn't that it? Because what is x minus mu? When you do x minus mu, that's how far away x is from the mean. And then why are we dividing by sigma? Because we're dividing by the standard deviation, so we know how many standard deviations we are away. Don't give me this, oh, another formula. You already had this. Yeah, that's right. We did Z is x minus x bar over s, isn't that what we did? Same exact formula. Why'd they change the letters? Well, because this is for population, right. For probability density, we also use the same ones we use for population. Now, you might say, why are they changing letters on me? And we don't have that answer for a couple more chapters, okay? We will show you why you have to care about population or sample, all right? All right, where are we? Here. We want to find, oh, okay, so let me show you a couple examples. So notice. Let's let x equal 69. Don't ask that yet. I want to let x equal 69. If I let x equal 69, then Z, what would it equal? Yeah. That's 0. Well, that's cool, because 69 was what? That's the mean, and what do I want the new mean to be? Okay, so it worked. Here, let's try another one. Let's let x equal 71.8. Okay. If I let x equal 71.8, what happens? Then Z is 71.8 minus 69 all over 2.8. Yeah, that's 2.8 over 2.8. That's 1. Why did I pick 71.8? Because that was one standard deviation away, and notice I get Z equals 1, right? You could take any x value and turn it into a Z value using this conversion. Now, Emily asked, will we always have the x values given to us? Well, real life, someone doesn't walk up to you and say, hey, Emily, x equals 42. But it is true that if you want to use this formula, you have to know what x is, right? So let's do a sample problem so we see how that works. Let's do problem 22. Doorway height. Yeah, so how tall should we make a door? Well, I'm glad this door is this height. I'll tell you what, down in my basement, we had a pretty low door. We have a ping pong table down my basement. I grew up playing ping pong and have a ping pong table. Well, when my cousins come over, see, they're above the mean in terms of height. They have to play like this. I'm at a huge advantage because they're ducked. Because they're going to bang their head on the top of the basement, right? So when you make a doorway, you don't want to make it just so the person of average height can fit through, right? It better be significantly above that. But obviously you don't want a 14-foot tall doorway because that's expensive, right? You don't want to do that. I mean, we did that all over Lakeland. There's your tuition money at work, right? Now let's do this now. When you read this problem, they're talking about a corporate jet, the Gulfstream 100, an executive jet, seats 6. How many of you own one of these? It says the doorway height is 51.6 inches. That's the only information they gave me. And now they're asking me questions. Part A. What percentage of adult men I'll just write fit. What the heck are we doing here? Well, my piece of advice for any problem in these sections, what's the first thing I told you should be doing? Let's draw a picture. All right, let's draw a picture. Here's a bell curve. What was the mean? This is mu equals 69, and I'm going to write down that sigma is 2.8 inches, right? Okay. So you tell me, where do I have to be on the picture on the x-axis if I want to fit? To the left. How far to the left? Well, there's 2.8 to the left. Is that far enough? No way. If I go another 2.8, is that far enough? I mean, you're way out here somewhere. And we have to be less than that to fit. Right? Way out here somewhere is 51.6 inches. Now, some of you might have drawn a line right here and put 51.6. You'll still get the problem right. And then you'll realize later, oh, my graph was way off. But you'll still get it right if you're drawing your sketch. Let me show you. What we do is we take this and we convert it to the standard normal deviation, right? Z, where the mean is 0, right? And the standard deviation is going to be 1. This is the standard normal distribution. Okay, so now we're at standard. Here's 1. Here's 2, right? Negative 1, negative 2. Now, how do I do it? Well, I use my Z conversion. Z equals x minus mu over sigma. So in my example, what is it I want to know? I want to compute, well, x minus 69 over 2.8. And what x value am I most interested in? Yeah, that's the only one they gave you, right? Because what I'm really trying to do is I'm trying to compute, here's what I'm trying to compute, I'll write it down. Compute the probability that x is less than 51.6. Because those are the people that could fit in the doorway. Does that make sense? It's a probability. It's a percentage. Now, I don't know it. But it's going to equal the probability that z is less than something. Now, I have to fill in what goes there. Well, what you do is you change the x value, 51.6, into a z value. So I'm going to compute 51.6 minus 69 over 2.8. That's what goes there. I want to show you a pitfall you could run into on your calculator. If I type in 51.6 minus 69, you want parentheses around it, because you have to divide that whole answer by 2.8. If you don't know the parentheses, it would only divide the 69 by 2.8. Okay, so I got, negative 6.21. Negative 6.21. What's the probability that z is less than negative 6? Holy moly. Yeah, it was even farther than the way I drew it. Negative 6.21 is way out here. I want to be to the left of that on the normal curve. And I'll tell you what the book says the answer is. This is almost impossible. In other words, almost nobody could get on that plane without having to duck through the doorway. You must know the mean, and what else do you have to know? The standard deviation. Otherwise, you can't convert it. That's right. So they have to tell you the heights are normally distributed, and here's the mean, and here's the standard deviation. But if they give you that, then you can do it. And we're going to find out soon that lots of times, like ridiculous amount of times, we get a normal distribution. And there's a mathematical reason. But that's coming after the quiz, so I don't want to trump it. Yeah? Yeah, you'd find the area here. I mean, it's going to be 0.0000000 whatever it is. It's ridiculous. We should do an example where you have one that you either look it up on the chart, plug it in. Yeah, I'll do it in the calculator. What the heck? No, I don't want to. It's so low. It's just ridiculous. Yeah. Well, that's the thing. What do you plug in? I guess you could go from negative 6 to 0 and then subtract from 0.5. Remember that trick we did the other time? I don't want to do that. This is not the best example for that. Okay. Let's do problem 24 because this may be helpful. Okay, so in problem 24, I got to watch my time because you guys have some group work to do. It says Tall Clubs International has minimum height requirements for men and women. So we'll do part A. It says, if the requirements are changed so that the tallest 4% of men are eligible, what is the new minimum height for men? All right, so this problem's a little different. I have a normal distribution of heights again. And I have mu is 69. And again, I'll just write down sigma is 2.8 because I'm going to use that. And the cutoff this time is somewhere up here, right? And it says the tallest 4% of men are allowed to be in Tall Clubs International. I'm not eligible, guys. So you have to be up here somewhere where that is 4%. And I guess the question is, what is Z? Okay. Well, if I were to look on the corresponding Z curve, looks like that. And again, we want this to be 4% of the area, so that's 0.04 right there. That's my z-score. I'm sorry, I shouldn't have written z here. You know what I should have written here? X. That should be x, because this is the actual heights, where x, again, is the heights. This is z right here. When you talk about a z-score is not a percent. Because a z-score tells you how far away you are on the z-axis, how far away you are from the mean. Right? The percentages are the same as the areas. Okay? So this is, when I wrote that 0.04, I'm talking about the area. 4% of the area under the curve is right there. I don't know what z is. They told me they want the top 4% of the people can be. So the question is, how tall is that, right? Notice 4% is here and 4% is here. Okay? It shows up both places. Although, when you go to the standard normal distribution, you know, this is actual area here. So, before I take your question, let me just show you one more thing. In order to compute x, what I'm going to do is compute z. And in order to compute z, I can use the table or I can use the calculator. But I need to know one more fact. And that is, I need to know how much area is to the left of the z-score. Well, that's 0.96. That's easy, sure. So this is 0.96. So you can look in your table now, and you can find what z value goes along with 0.96. Or, do you remember how to do this on the calculator? We're going to do inverse norm, right? Inverse normal distribution is what that really stands for. So I'll go, let's see, second distribution, inverse normal, and I have 96% of the area. And the question is, what z value do I get? Oh, z is 1.75. 1.75. Now you're almost done. That's the z-score. I'm not done yet. That's the z-score for 0.96. That's right. If you looked up on the chart 1.75, you would find 0.96 approximately. Okay? See, now I have to go back and I have to compute x. Now wait a minute. We had a formula going this way. We knew that z equals x minus 69 over what? 2.8. Because it's x minus mu over sigma. Well, I know the z-score, guys. So I could put 1.75 right here. X minus 69 over 2.8. Okay, now I'm relying on an algebra skill or two here, because you have to solve for x. Right? Do you see what I have? I have the z value, but what do I want to know? So what would I do to both sides of this equation? We can multiply by 2.8 on both sides. Why did you do that? Because that'll cancel out the dividing. On this side, you'll just have x minus 69. And then I can do 2.8 times 1.75 on this side. All right, what's that equal? 2.8 times 1.75. 4.9. Okay. And now my algebra skills coming back. What's the last step here? Okay, add 69. So x is going to equal 73.9. Okay. So how tall do you have to be to join Tall Clubs International? You have to be taller than 73.9. So yeah, if you're 6'2", that'd be 74. They'd let you in. 6'2" and above, they'll let you in this club. David. Let's see. I guess you're right. Matter of fact, the book does that. The book says, hey, we can save you some steps by giving you another formula. I don't like another formula. That's why I didn't show it. But some people do. And so what the book does is they do this. Z is x minus mu over sigma. And then what David noticed is, hey, what did you actually multiply by? You multiplied both sides by sigma. So sigma z is x minus mu. And then you added mu to both sides. So their formula is going to be x equals, well, this. Mu plus sigma z. But to me, I wouldn't memorize anything. To me, I would memorize just the one I gave you. Z is x minus mu over sigma. And I would just use that anytime I need it. And if I know x, I can get z. And if I know z, I can get x. Because I can do a little bit of algebra. Let's see. One man randomly selected. Find the probability that he weighs less than 174 pounds. I'm going to let x be, well, weight in pounds. And then I'm going to draw a picture of the x distribution. Do they tell me the mean? So the mean is 172. I'm going to draw that. And I'm going to write mu is 172. And do they tell me the standard deviation? That's good. Okay. So now, and by the way, 29, remember, that's about right here, one standard deviation. So that'd be I guess 201, right? Would be right around there is 201. You don't need to draw that, but I like to. And now, when I go to answer Part A says, find the probability that he weighs less than 174. Find the probability that x is less than 174. So on the picture, that's about right there. So already, I know something about my answer. Approximately, what should my answer be? It better be more than 50%. See, I'm finding a probability. Why do I say it has to be more than 50%? 174 is bigger than the mean. And 172, we know would be 50%. Is this okay so far? Okay. So now how do I compute it? Well, the probability that x is less than 174 is equal to the probability that z is less than something. What is the something? Remember, it's going to be z is always equal to x minus mu over sigma. So in my example, it's going to be 174, which is my x, minus 172, which is the mean, all over what? 29. So this is the probability that z is less than 2/29, whatever that is. Okay, to finish, you can look on the chart if you want. You know, you do 2 divided by 29, right? You get some value. That's the z-score, right? We want z to be less than 0.0689. Okay? Now, how do I do this? Well, here's what I would do, I guess, for now. If I go to normal CDF, first of all, you look on your chart and you got it. That's one way. But if I want to do it here, I hit second distribution, normal CDF, and I'm just going to go from 0, comma, 0.0689. And it says 0.027. Now, what is it that I just found? I found how far it is from, yeah, I don't have the picture, but basically I found this percentage in green. Right? So if you do that, what's the last thing I have to do to this? Yeah, you have to add the 50% on for the other part because we want to be greater than. And so there's your answer, 52.7%. Okay? Again, because when I typed it in the calculator, I was typing in the z-score. And the z-score we said is 0.0689, right? That's the z-score for 174. And the z-score for 172, of course, is 0. So what the calculator gave me was this green strip of area. And that was, 0.027. Right? But I want the whole area, everything to the left. So I added on the extra 0.5 and got point. I knew the answer would be bigger than 0.5, right? That's how I got it. Okay? All right, guys. Oh, actually, it said what to do. Yeah, you don't need the whole thing. You go however far you around. I think it says go to 10th place in the book or something like that. It's fine, buddy.
So when we're showing that like on the test, our test example, how do you show the z-score? We're just using the second variations. How do you show that we're doing that?
Well, just what I have up here is all you need. Like this.
Okay.
Okay? There's no homework due today. No, homework will be due. And then I changed it. I sent an email out. And I said, but that same email is due Tuesday. I mean, that same homework. That's sections 2 and 3. You didn't do 6-3 at all. Yeah, that's... Check. You can turn that in for your 6-2. If you're confident, you're done with it, only do 6-3. Most people didn't even try it.